You guys, y'all, shh. You were supposed to have done the limiting reagents on Friday. Okay, and I know some people didn't, and I know some people were confused.
That's the thing we did, right?
No, this is new.
Okay.
This is the work day for today. I'm just going to go over what I talked about on Friday to make sure that there aren't any questions. And for most of you, it's not the mass to mass part that's hard. You've gotten that. It's which one is limiting and which one is excess. So the first part of the opener was the one that you guys were supposed to have answered Friday. It says, what does it mean if something is an excess or if it's limiting? If it's limiting, it stops. That's the important one. If it's an excess, it's going to have extra left over, and that's not the important one. So the opener for today is the second half of what's up here. It says, would you use a limiting or an excess reagent to do a calculation? Which is the important one? The limiting. So with these problems, if you didn't notice, I give you both reactants. I give you starting amounts of both reactants. You pick one. I always pick the first thing that's listed. And you compare it to the other reactant. You either have more than enough, and if you have more than enough, it's excess, or you don't have enough. And if you don't have enough, then it's limited. It's one or the other. And so there's not a section of notes. I'm just going over what you guys were supposed to have done Friday. If you didn't do it, then you're behind. It starts off with this like McDonald's hamburger kind of thing, where it says that it takes 2 all beef patties, 2 sesame seed buns, 4 pickles, a ketchup to make 1 burger. So this is essentially the same thing as a chemical reaction, Jared. What?
Why do schools make us learn science when we don't use it?
It's one of the 4 main disciplines. You're going to do it in college too, no matter what. So what I did was I pulled it over. We want to know of the 4 parts that make up a hamburger, what's the one that's going to be the most important? Which means if you run out of it, you can't make any more burgers. It's the same thing as the mass, but this is just like a 1-step mole, where I'm going to start with 20 of the patties, and then I'm going to bring the patties down, and I'm changing it to the burger. My coefficient for a patty is a 2, and I guess I set them all up first. I can't remember. So I'm starting off with 20 all beef patties, 50 pickles, 10 ketchups, and 16 sesame seed buns. I'm trying to figure out, it's just not oxygen and copper and iron. It's using it from a food point of view. But I'm still going to, just like when you guys are doing the mole to mole ratio, you're using the coefficients in front of now the parts of the hamburger, where the patty is a 2, the burger is going to be a 1. 20 divided by 2, I can make 10 full hamburgers if I have enough of everything else. So if I move on to the pickles, 4 pickles per burger. So this is going to be a total of 12. You can't make 12 and a half. You can make 12. You're going to make half a burger. You're going to do, the burger still gets a 1. The ketchup gets a 1. 10 divided by 1 is 10. And then the patties, or the buns, gets a 2, and the burger gets a 1. Which is the most important part of making a hamburger according to these numbers? The bun, because it's the least amount. That is the limiting reagent. That's the thing that's going to control the rest of however many you can make. It's just we're not doing it with hamburgers and like pickles and stuff. We're using things like oxygen and iron and copper and hydrogen gas. Once again, the important one, when you figure out who the limiting reagent is, you have to use that to calculate your product. The excess is extra, it's left over. So let me go to, so in the question, that's how much you have. When you solve for an answer, that's how much you need. This is the only part that's really tricky. And when I was going through and looking at the submissions that you guys gave, some of you, I don't know if it was this class or if it was 8, your math is perfect, but you're not comparing them to each other the right way. So
Now we don't be that smart.
It's chemistry.
I'm not that smart.
It's chemistry.
I've still got
So I'm starting with 5 grams of each reactant. I always just pick the first thing that's listed. It's just, I don't know, it's just the way I do it. So I'm going to start with 5 grams of sodium. When I look it up on the periodic table, it's 22.99 grams. I could have started with the chlorine, but I'm not going to. And you don't want to, you're starting with one and comparing it to how much of the other is necessary. I have 5 grams of each. I'm about to calculate how much of chlorine I need for 5 grams of sodium to be perfect, to not waste anything. So I have to switch to the other reactant, and then I'm going to use its molar mass to go to its grams. Where 1 mole of sodium is 22.99 grams. I have the sodium gets a 2, the chlorine gets a 1. And then 1 mole of chlorine is 70.90 grams. And then I cleaned everything up. So I would do 5 times 70.90 divided by, and then you would use parentheses, or you could just multiply out the bottom, but 22.99 times 2. And according to this, I need 7.71 grams. Do I have enough? No, I only have 5. I need this amount. I only have this amount. This is the one that's important. I had people that were doing it backwards, which is very, very, very common. The problem tells you how much you have. Your stoichiometry tells you how much you need. You have to figure out if you have enough. And then I went on just because it's not always going to work out that it works this way. Sometimes this would be less than what you have, which means that's an excess, and then the other guy would be limited. So I went ahead and did the same thing both ways with this one. I'm starting with 100 grams of acetylene because that's the first thing that I saw. Its mass is going to go down. Its mole is going to go up. You're going to bring down moles. This is where you switch using the balanced equation. And then you switch back to the other substance mass. Just drop the grams, change to its mole. Drop the mole, change to the other substance's mole. Drop the mole and go to its molar mass. This is the same process. It's a mass. I get these from here. This is the molar mass of acetylene. This is the molar mass of oxygen gas. And I cleaned it all up. And if I do all this math, I need 307.2 grams of oxygen. Do I have enough? No. So that means the oxygen is a limiting reagent. And then I went ahead and picked the other guy because you're not always going to be starting with the thing that's going to force the limiting reagent. Sometimes you start with the thing that forces the excess. So if I did it the other way, this is the exact same thing I just did, it's just the other direction. So if you start with 100 grams of oxygen, you need 32.55 grams of acetylene. Do you have enough? I need 32.55. I have 100. Do I have enough? Yes, I have way more than enough. I have like 3 times the amount that I need. So that means that this guy is limiting. I'm sorry, this guy, the acetylene is excess and the oxygen is limiting. Like I said, I saw some of you that did, this is the one for tomorrow. You did your math great, but what you didn't do was compare it the right way. So once again, your math is how much you need. Your problem tells you how much you have. Now, today's paper, I gave you the answers. You have to figure out the limiting reagent first. And the way that this is done is you're going to determine in a mass, the limiting reagent. You have to use whichever one is limiting, not the answer to this. Whichever one is limiting, like let's say, I don't even know if it's the right thing. Let's say that the C3H8 is the limiting reagent. Then you have to use the 14.8 grams to run the problems. Don't use the thing that's in excess. Now, the first one, it's the same thing. There's 3 problem sets. It's a total of 9. You're going to figure out the limiting reagent, mass. Then you're going to go from grams to moles, which is a 2-step conversion. And then on the bottom, you're going to do a 3-step mass. So if you're going from grams to moles, you're going from grams of your given, whichever one's the limiting, to 1 mole. Then you're going to switch from the moles of whatever your given substance is to your moles of your unknown from the balanced equation. So your step B all of them will be this. I don't know what your substances are. It depends on the limiting reagent. And then you're going to do a mass. It's going to look exactly the same as the top one. Given, grams of the starting substance. So this part will look exactly the same, but then you're switching it to whatever it's asking you to. Like this. I don't think it's going to let me write on the board. I really don't. I can try. I don't even see my smart ink though. Let me see. Yeah, it hates me. The smart board hates me. Okay, so for those of you that are online, today is a work day. If you did not, because I just went through those notes super